Hello everyone, welcome back to my channel. So in this question we have to find out the domain and the range of the following functions. So let's see how to solve this. So let us take the first question, which is fx is equal to 3x plus 7. Now we substitute different values of x and see whether fx turns out to be defined or not. So we will make a table of x and fx. On substituting x is equal to minus 3, in this equation we will get fx is equal to minus 2. On x minus 1, fx will be 4. On x 0, fx will be 7. And on substituting x is equal to 1, we will get fx is equal to 10. So here we see that fx is defined for all real values of x. Hence, there is no domain restriction. So, domain of the function can be written as domain of f is equal to x such that x belongs to R. It means set of all real values. Or it can also be written as domain is equal to minus infinity to infinity. Now for range, we will substitute fx is equal to y. So this will become y is equal to 3x plus 7. Now expressing x as a function of y, we will get 3x is equal to y minus 7, or x is equal to y minus 7 divided by 3. Now we will substitute different value of y and see x turns out to be defined or not. So this was the given equation. Now we will put y is equal to minus 1, 0, 4, 5 or any real number, and we see that x is defined for all values of y. So range of the function will be y such that y belongs to R, or R is minus infinity to infinity. Now let us take the second question, which is fx is equal to x square plus 1. Now for domain, we will substitute different values of x and see whether fx is defined or not. So here we will substitute x is minus 3, minus 1, 0, 2 and so on, any number, and fx will be, for minus 3 it will be 10, and for minus 1 it will be 2, for 0 1 and so on. So it is clearly defined for all values of x. So domain of the function will be x is such that x belongs to R, that is set of all real values, or this can be written as domain is minus infinity to infinity. Now for the range, we will replace fx with y. So y is equal to x square plus 1. Now express x as a function of y. So we will get x square is equal to y minus 1, or x is equal to square root of y minus 1. Here we have square root in the function. So here y minus 1 should always be positive for x to be defined. So y minus 1 should always be greater than or equal to 0. Or y should always be greater than or equal to 1. So range of the function will be y such that y belongs to R, where y is always greater than or equal to 1. Or range of the function is 1 to infinity, where 1 is included in the range. Now third question is fx is equal to square root of x minus 2. Now to find domain of this function, we see that there is a square root in this function. So x minus 2 should always be greater than or equal to 0. Otherwise this will become negative and fx will become undefined. So x should be always greater than or equal to 2. So domain of the function will be x such that x belongs to R, x is always greater than or equal to 2, or domain is from 2 to infinity, where 2 is included. Now for the range of this function, we will substitute fx with y. So y is equal to square root of x minus 2. On squaring both sides, we will get y square is equal to x minus 2. Now we will express x as a function of y. So x is equal to y square plus 2. Now Here x is defined for all values of y. So we can say that x is defined for all real values of y. So range should be minus infinity to infinity, but minus infinity is not included in this range because here we have square root and this should always be positive. So range will be 0 to infinity, or range of the function is y such that y belongs to R, where y is always greater than or equal to 0. Now let us take the fourth question, which is fx is equal to 3x plus 2 divided by x minus 3. Here we have x minus 3 in denominator. So for domain, denominator should not be equal to 0. So x minus 3 should not be equal to 0. That is, x should not be equal to 3. So domain is x is such that x belongs to R, where x is not equal to 3, or domain is equal to minus infinity to 3 union 3 to infinity, where this bracket means that 3 is not included in the domain. Now for the range, we will replace fx with y. So y is equal to 3x plus 2 divided by x minus 3, which will give y x minus 3 is equal to 3x plus 2, or y x minus 3x is equal to 2 plus 3y, or x is equal to 2 plus 3y divided by y minus 3. Here we have y minus 3 in denominator. So y minus 3 should not be equal to 0. That is, y should not be equal to 3. Otherwise denominator will be 0 and x will be undefined. So range will be y such that y belongs to R, where y is not equal to 3. Or range of the function is minus infinity to 3 union 3 to infinity, where 3 is not included in the range. Now question 5 is fx is equal to x cube. Now for domain, we will substitute different values of x like minus 5, minus 1 and so on, and we will see that fx is defined for every real value of x. Hence there is no domain restriction. So domain of the function will be x is such that x belongs to R, set of all real values, or domain is minus infinity to infinity. Now for the range, we will replace fx with y. So y is equal to x cube. Now x is equal to cube root of y. Here we have cube root, which is odd indices. So here y can take any value, that is minus 2, minus 1, 0, 3 or 4. X will always be defined for all real values. Range of the function will be y is such that y belongs to R, or R is minus infinity to infinity. Now question 6 is fx is equal to x square minus 1. Now on substituting x minus 3, minus 1, 0 and so on, fx is defined for all values of x. So domain of the function will be domain is equal to x such that x belongs to R, or domain is minus infinity to infinity. Now for the range, we will substitute y in place of fx. So y is equal to x square minus 1, or x is equal to square root of y plus 1. Here we have square root. So x is defined only when y plus 1 is positive. So y plus 1 should always be greater than or equal to 0. That is, y should be always greater than equal to minus 1. So range is y such that y belongs to R, where y is always greater than equal to minus 1. Or range is minus 1 to infinity, where minus 1 is included. Now question number 7 is fx is equal to 5x divided by x plus 3. So for domain, we see that this function has x plus 3 in denominator. So x plus 3 should not be equal to 0. So we will find values that makes denominator 0. So we will put x plus 3 is equal to 0, which will give x is equal to minus 3. So domain is x such that x belongs to R, x is not equal to minus 3. Our domain is minus infinity to minus 3 union minus 3 to infinity, where minus 3 is not included. Now for the range, we will replace fx with y. This was the function. So on substituting fx as y, we will get y is equal to 5x divided by x plus 3, or y x plus 3 is equal to 5x, which will give yx plus 3y is equal to 5x, or y x minus 5x is equal to 3y, or x y minus 5 is equal to 3y, or x is equal to 3y divided by y minus 5. So here we have y minus 5 is denominator, so this should not be equal to 0. So we will find out the values that will make denominator 0. So for that, we will put y minus 5 is equal to 0, which will give y is equal to 5. It means y should not be equal to 5, otherwise denominator will be 0. So range of the function will be x such that x belongs to R, where x is not equal to 5, or range of the function is minus infinity to 5 union 5 to infinity, where 5 is not included. Now question number 8 is fx is equal to x minus 5 divided by 2x plus 6. So for domain, denominator should not be equal to 0. That is 2x plus 6 should not be equal to 0. Now we will find the values that makes denominator 0. For that we will put 2x plus 6 is equal to 0, which will give 2x is equal to minus 6, or x is equal to minus 3. So minus 3 should not be taken in domain. That is, domain is x such that x belongs to R, where x is not equal to minus 3, or domain is minus infinity to minus 3 union minus 3 to infinity, where minus 3 is not included. Now fx is equal to x minus 5 divided by 2x plus 6. For range, we will substitute y in place of fx. So y is equal to x minus 5 divided by 2x plus 6, which will give y 2x plus 6 is equal to x minus 5, or 2xy plus 6y is equal to x minus 5, or 2xy minus x is equal to minus 6y minus 5, which will give x 2y minus 1 is equal to minus 6y minus 5, or x is equal to minus 6y minus 5 divided by 2y minus 1. Now here domain should not be equal to 0. So 2y minus 1 should not be equal to 0. Now we will find the values that makes this 0. For that we will take 2y minus 1 is equal to 0, which will give 2y is equal to 1, or y is equal to 1 by 2. Therefore range is all real number except 1 by 2. So range of the function will be y such that y belongs to R, y is not equal to 1 by 2, or range is minus infinity to 1 by 2 union 1 by 2 to infinity. I hope this video was easy to understand. If you liked the video, please give it a thumbs up and please subscribe to my channel for more such questions. Thanks for watching.